December 1941. Murmansk Docks, Soviet Union. The brown exhaust from senior mechanic Dmitry Volkovich's breath hung in the air at -38 degrees Fahrenheit as he circled the American truck that had just been unloaded from a British convoy ship. 27 years, a mechanic, graduate of the Gorky Automotive Institute, veteran of the Finnish Winter War. He had maintained every Soviet vehicle in service and examined captured German equipment. What stood before him now, this Studebaker US-6, with its canvas cover dusted in frost, appeared to be a cruel joke from the capitalists. Volkovich knocked his wrench against the truck's front fender. The metal rang thin, almost hollow. Soviet Gaz AA trucks used thicker steel, properly hardened for winter service. This American metal felt soft, inadequate. He moved to the engine compartment and released the hood latches. The Hercules JXD engine sat exposed, its components laid out with agricultural simplicity. The carburetor was a basic single-barrel design, nothing like the sophisticated dual-venturi systems Soviet engineers had developed for cold-weather operation. The fuel lines ran directly from tank to engine, with minimal shielding against temperature extremes. Most troubling, Volkovich could find no evidence of winterization equipment. No engine blankets. No preheating manifolds. No insulated fuel line wrappings. The oil pan showed no provision for external heating elements. 15 meters away, a Soviet Gaz AA sat silent, its engine frozen despite having been preheated for 3 hours that morning. The Gaz represented Soviet automotive achievement, designed specifically for Russian winter conditions through careful engineering and extensive cold weather modifications. Every Soviet mechanic knew the proper procedure. Fill the oil pan with hot water first, then drain it and replace with pre-warmed oil. Wrap the engine block in insulated blankets. Heat the carburetor with a blowtorch. Prime the fuel system manually. Cover the radiator partially to maintain operating temperature once started. The process required expertise, dedication, and typically 2 to 3 hours of preparation before the engine would turn over in temperatures below -20 degrees Fahrenheit. The Americans had sent no such instructions with their trucks. The manifest listed standard 30-weight oil, regular gasoline, conventional starting procedures. Volkovich pulled out his maintenance log and began documenting what he saw. The entries reflected his training and experience. Studebaker US-6 examination, December 7th, 1941. Metal construction appears substandard, insufficient thickness for thermal stress. Engine design primitive compared to Soviet equivalents. Carburetor lacks cold weather venturi modifications. Electrical system uses 24-volt configuration. Purpose unclear. Likely adds unnecessary complexity. Fuel system has no visible winterization features. Assessment. Vehicle will require extensive modification for Russian winter service, or will experience catastrophic failures within 200 kilometers of operation in current temperatures. Volkovich's assessment was shared by every Soviet mechanic who examined the first American truck deliveries that winter. The vehicles represented everything Soviet engineering education taught them to avoid. American industrial production was quantity over quality, mass manufacturing over precision craftsmanship, capitalist corner cutting over socialist thoroughness. The trucks looked hastily assembled, their components selected for manufacturing speed rather than operational excellence. The electrical wiring seemed almost carelessly routed. The suspension appeared too light for serious loads. The transmission felt loose, its tolerances too broad for precision operation. Soviet automotive doctrine emphasized that cold weather required specialized engineering. The Gaz AAA and its successor, the Gaz MM, had been designed with hundreds of specific features to address winter operation. Tighter tolerances to maintain compression ratios in extreme cold. Harder steel alloys to prevent metal fatigue. Complex fuel delivery systems to prevent icing. Multiple redundant heating systems. Soviet engineers understood that Russian winter demanded respect through engineering sophistication. The American trucks displayed none of this sophistication. They seemed designed by people who had never experienced real winter, who had no conception of what minus 40 degrees Fahrenheit did to metal, to fuel, to lubricants, to electrical systems. The irony was not lost on Volkovich. The Soviet Union desperately needed vehicles. The German invasion had destroyed thousands of trucks. Soviet factories were being evacuated east, production disrupted. The Red Army was losing vehicles faster than they could be replaced. And now the Americans were sending these simple machines, these unsophisticated trucks that would certainly freeze solid the moment they left coastal ports for the Russian interior. Orders arrived that afternoon. A convoy would depart Murmansk for Moscow in 4 days. 50 American Studebaker trucks. 50 Soviet Gaz AA trucks. Parallel columns for comparison. Distance, 1,400 kilometers. Expected temperatures, minus 35 to minus 45 degrees Fahrenheit. Volkovich was assigned as lead mechanic for the American column. His orders were explicit. Maintain the American trucks, document their performance, report failures, and recommend modifications necessary for continued service. Volkovich accepted the assignment with professional resignation. He expected to spend most of the journey recovering frozen American trucks, jury-rigging repairs with whatever materials the convoy carried, and ultimately recommending that future American deliveries be rejected as unsuitable for Soviet conditions. He gathered his tools, packed extra blankets for engine warming, collected blowtorches for carburetor heating, and prepared for what he assumed would be a constant maintenance nightmare. The convoy was scheduled to depart at dawn on January 12, 1942. Volkovich spent the intervening days training Soviet drivers on American truck operation, though he suspected the training would prove academic when the vehicles began failing. On the night of January 11th, he stood again beside the first Studebaker he had examined. The temperature had dropped to minus 41 degrees Fahrenheit. The Soviet Gaz AA next to it sat entombed in frost, its engine requiring hours of preparation before it would start. Volkovich wrote a final note in his maintenance log. "We will see how capitalist simplicity performs when Mother Winter tests it properly." Dawn arrived at 0600 hours on January 12, 1942, with temperatures holding at minus 39 degrees Fahrenheit. The Soviet mechanics began their morning ritual with the Gaz AA trucks 2 hours before scheduled departure. Volkovich watched them work through the preheating sequence he had performed thousands of times. They built fires beneath engine blocks, heated oil in metal containers over flame, wrapped carburetors in cloth soaked with warm water, manually cranked engines that resisted every rotation. The process was familiar, methodical, necessary. 3 Gaz trucks experienced cracked engine blocks during the heating process, thermal shock fracturing metal that had become brittle overnight. 2 more refused to start despite proper procedure. By 0800 hours, 45 Soviet trucks sat running, their engines clattering in the frozen air, exhaust forming clouds that hung motionless in the still morning. The American column prepared differently. Soviet drivers approached their assigned Studebakers with uncertainty, following the simple instructions Volkovich had translated from English manuals. No preheating, no special procedures. Just turn the key and press the starter. The first driver, a veteran named Alexei Morozov, sat in the cab of his Studebaker and looked back at Volkovich with obvious skepticism. The temperature was minus 39 degrees Fahrenheit. The truck had sat motionless all night. Soviet doctrine said the engine would be frozen solid, the oil thick as tar, the fuel lines blocked with ice. Morozov turned the key anyway. The Studebaker's starter motor engaged immediately. The engine turned over once, twice, caught, and settled into a smooth idle. The sound carried across the assembly area, distinct from the rough clatter of the Soviet engines. Morozov sat motionless for several seconds, then climbed out and opened the hood. The engine was barely warm, yet running steadily. He looked at Volkovich. Neither man spoke. Across the American column, 49 more Studebakers started on first attempt. 50 trucks, 50 successful starts, 0 failures. The convoy departed at 0830, hours, 30 minutes ahead of schedule, because the American trucks required no preparation time. The first mechanical failure occurred at kilometer marker 150. A Soviet Gaz AA dropped out of formation, its fuel line frozen despite insulated wrapping. Volkovich's assistant mechanics worked for 40 minutes with blowtorches before the truck could restart. At kilometer marker 190, another Gaz suffered a cracked engine block. The thermal stress of operation in extreme cold had found a weakness in the casting. The truck was abandoned, its cargo redistributed to other Soviet vehicles. All 50 American trucks continued without incident. By evening of the first day, the convoy had covered 230 kilometers. Temperatures had dropped to minus 42 degrees Fahrenheit. The Soviet mechanics established camp and immediately began evening maintenance on the Gaz trucks, a process requiring 2 to 3 hours. Oil changes with specially formulated winter lubricants, fuel system inspections, engine blanket installation, carburetor adjustments for cold air density. The American trucks sat idle, their drivers simply turning off the engines and walking away. Volkovich found this behavior irresponsible, negligent even. Proper vehicle maintenance in winter conditions required constant attention. He approached the nearest Studebaker and began his own inspection. The engine was still warm 2 hours after shutdown. Volkovich placed his bare hand on the engine block and felt retained heat, impossible but undeniable. The metal mass held temperature in a way Soviet engines did not. He examined the oil dipstick. The lubricant remained fluid, showed no signs of cold thickening. He traced the fuel lines with his flashlight. No ice formation, no blockages, no frost accumulation, despite hours of sub-zero exposure. The electrical connections showed no corrosion or cold damage. The battery, a standard lead-acid design, somehow maintained charge and capacity despite conditions that typically reduce Soviet battery performance by 70%. Soviet mechanics gathered around Volkovich's inspection that night, drawn by professional curiosity and growing confusion. Senior Lieutenant Pyotr Kuznetsov, chief mechanic for the Gaz column, voiced what others were thinking. "This should not work. The design is wrong, too simple, too crude, but it works." Another mechanic suggested the Americans had somehow pre-treated the trucks with special chemicals or coatings not visible to inspection. Another proposed that the fuel was specially formulated, though testing showed it was standard gasoline, identical to Soviet specifications. Volkovich opened his maintenance log and began documenting observations that contradicted his training. The American carburetor design, so primitive in appearance, actually prevented ice formation through constant fuel movement. The fuel system routing kept liquid circulating even during idle, preventing freeze points. The 24-volt electrical system, which he had dismissed as unnecessary complexity, provided substantially more cranking power in cold conditions than Soviet 12-volt systems. The oil circulation system maintained pressure that prevented cold soak when the engine was shut down. Day 2 began at minus 42 degrees Fahrenheit. 5 Soviet Gaz trucks would not start despite 3 hours of preheating and proper procedure. The engines had sustained internal damage during the previous day's operation, thermal cycling and extreme cold causing failures in pistons, valves and bearing surfaces. The American trucks started instantly, all 50 engines firing on first attempt. Volkovich rode in the lead Studebaker that morning, watching the temperature gauge, listening to the engine sound, feeling the vehicle's response to road conditions. The truck carried 3 tons of cargo, half a ton over its rated capacity, yet performed smoothly. The transmission shifted cleanly despite cold that should have made the lubricant too thick for proper gear engagement. The suspension absorbed impacts from frozen road irregularities without the harsh jarring typical of Soviet trucks. At kilometre marker 400, the pattern was undeniable. Soviet gas count, 38 operational, 12 abandoned or broken down. American Studebaker count, 50 operational, 0 failures. Volkovich's maintenance log entries became increasingly detailed and increasingly troubled. January 13th, 1400 hours. American trucks continue operation without maintenance requirements. Soviet doctrine states, this is impossible. Observation states, it is fact. Carburetor design appears to prevent fuel icing through geometric simplicity rather than mechanical complexity. Engine thermal mass design retains operational heat between uses. Electrical system provides reliable cold weather starting through higher voltage application. Conclusion. American engineering philosophy differs fundamentally from Soviet approach. They have designed for worse conditions rather than optimal conditions. This may be accidentally superior to our intentional design. By the 3rd day, at -40 degrees Fahrenheit, the Soviet column had lost 15 trucks to cold-related failures. The American column maintained perfect operational status. Volkovich began systematically comparing design elements, documenting not just what worked, but why it worked. Soviet trucks used tight tolerances, precision manufacturing, exact specifications. In extreme cold, these tight tolerances became liabilities. Metal contraction caused binding, seizing, mechanical interference. American trucks used looser tolerances, rougher finishes, broader specifications. The sloppiness he had initially dismissed as poor manufacturing actually allowed for thermal expansion and contraction without mechanical binding. Soviet engines used harder steel alloys for durability and precision. In extreme cold, these harder steels became brittle, prone to fracture. American engines used softer steel that remained ductile at low temperatures. The material that seemed weaker was actually stronger where it mattered. Volkovich sat in his tent on the night of January 14th and wrote a passage in his personal journal, separate from his official maintenance log. Everything I was taught is backwards. Complexity does not equal superiority. Precision does not equal reliability. The Americans have built trucks for chaos. We have built trucks for perfection. Chaos is what we have. They win. The convoy reached Moscow suburbs on January 18th after covering 1,400 kilometers through record cold. Final count at the destination gate told a story Soviet automotive engineers could not ignore. Soviet Gaz AA trucks, 28 arrived operational, representing a 44% failure rate over the journey. American Studebaker trucks, 50 arrived operational, representing a 0% failure rate. The mathematics were absolute and undeniable. Volkovich submitted his report to Red Army Motor Transport Command on January 20th. The document ran 47 pages, filled with technical diagrams, comparative measurements, and temperature logs that documented every kilometer of the journey. His conclusion challenged Soviet automotive doctrine directly. American trucks succeeded, not despite their simple design, but because of it. The recommendations section requested immediate authorization for systematic testing to understand why capitalist engineering outperformed socialist precision. Red Army Command approved the request within 72 hours. By early spring of 1942, the Gorky Auto Plant had established a dedicated testing facility with 100 American trucks of various types and 100 Soviet trucks for controlled comparison. The protocol was comprehensive. Temperature testing from plus 86 degrees Fahrenheit to minus 58 degrees Fahrenheit. Load stress testing from empty to 3 times rated capacity. endurance testing over varied terrain, maintenance requirement documentation under field conditions. Every measurement recorded, every failure analysed, every success documented. The Studebaker US-6 specifications revealed design priorities fundamentally different from Soviet engineering. The Hercules JXD engine displaced 320 cubic inches and produced 87 horsepower, modest figures by performance standards but selected for reliability under stress. Cold start capability functioned to -40 degrees Fahrenheit without any preheating, a capability Soviet engineers had considered impossible without extensive winterization systems. Time to operational temperature averaged 3 to 5 minutes from cold start, compared to 15 to 25 minutes for Soviet engines, even with preheating. Maintenance intervals extended to 3,000 miles between required service, double the Soviet standard. Load capacity was rated at 2.5 tons, but the truck routinely carried 4 tons or more without mechanical failure. Fuel consumption ran 8 to 10 miles per gallon when loaded, efficient given the performance. The 24-volt electrical system provided reliable starting capability to -50 degrees Fahrenheit, temperature ranges where Soviet 12-volt systems failed completely. Soviet Gaz AA specifications, by comparison, showed the limitations of complexity. The Gaz AA engine displaced 3.3 litres and produced 50 horsepower, substantially underpowered for its weight class. Cold start capability ended at -15 degrees Fahrenheit, without extensive preheating procedures that consumed hours of mechanic labour. Time to operational temperature required 15 to 25 minutes, even with proper preheating, assuming the engine survived the thermal shock. Maintenance intervals occurred every 1,500 miles, requiring constant mechanic attention. Load capacity was rated at 1.5 tons, and the truck struggled with loads above 2 tons, suffering transmission and suspension failures under stress. Fuel consumption reached 11 to 14 miles per gallon when loaded, poor efficiency for the limited capability. The 12-volt electrical system became unreliable below -20 degrees Fahrenheit, temperature conditions common throughout Soviet winter. The controlled testing through spring and summer of 1942 produced results that Soviet engineers found difficult to accept, but impossible to deny. American trucks started successfully 100% of attempts at -40 degrees Fahrenheit. Soviet trucks started successfully 34% of attempts at the same temperature. American trucks required 1/8 the maintenance hours per 1,000 miles of operation. Soviet trucks demanded constant mechanic attention, consuming labor resources desperately needed for weapon systems and combat vehicle maintenance. American trucks carried 60% more weight reliably, increasing logistics capacity without increasing vehicle count. Soviet trucks operated at rated capacity only, limiting supply chain efficiency. Volkovich spent months analyzing why American design succeeded where Soviet design failed. The answers challenged everything Soviet engineering doctrine taught. American engineers used looser tolerances in manufacturing, allowing components to expand and contract with temperature changes without binding or seizing. Soviet tight tolerances, designed for precision, became failure points when metal contracted in extreme cold. American engineers selected softer steel alloys that remained bendable at low temperatures, preventing the brittle fractures that destroyed Soviet engines. Soviet harder steels, chosen for durability, shattered under thermal stress. American design philosophy emphasized fewer components, creating fewer potential failure points. Soviet design added specialized systems for specific conditions, each system representing another component that could break. American systems were integrated, each supporting the others in ways that created unexpected resilience. Soviet systems operated independently, meaning single failures cascaded into total breakdowns. The fuel system comparison revealed the deepest difference in philosophy. Soviet engineers had designed complex carburetor systems with multiple venturis, specialized jets, and temperature-compensating mechanisms. Each component required precise adjustment and regular maintenance. In extreme cold, moisture in the fuel would freeze in these narrow passages, blocking fuel flow completely. American engineers had designed simple single-barrel carburetors with wide passages and constant fuel movement. The design looked primitive, almost agricultural, but the wide passages never accumulated enough ice to block fuel flow. The constant circulation prevented freezing even in temperatures that stopped Soviet systems completely. Volkovich wrote in his analysis, "Americans designed for chaos. We designed for perfection. Their trucks are built to work when everything goes wrong. Our trucks require everything to be exactly right. War is chaos. The American philosophy wins." The political implications troubled him more than the technical findings. If capitalist industrial methods produce superior results through apparent accident, what did this say about socialist central planning and scientific design? The question had no safe answer in 1942 Soviet Union, so Volkovich confined such thoughts to journals he kept hidden. By late 1942, the Red Army was placing massive orders for American trucks under the Lend-Lease program. Soviet production continued, but American vehicles increasingly dominated Soviet logistics operations. The trucks that Volkovich had dismissed as capitalist junk in December 1941 were now the backbone of Soviet military transport. The Studebaker became known simply as Studer among Soviet troops, a nickname conveying respect bordering on affection. Soldiers trusted American trucks more than they trusted Soviet officers, a sentiment expressed in dark humor but rooted in operational reality. The testing program concluded in January 1943 with recommendations that remained classified for 50 years. Soviet engineers should study American design philosophy and adopt principles of simplicity and tolerance for imperfection. Soviet manufacturing should prioritize reliability over precision. Soviet automotive doctrine should recognize that the best design for Russian conditions was not the most sophisticated design, but the most resilient design. The recommendations were filed, studied by senior engineers, and quietly implemented in ways that would not acknowledge capitalist superiority. Soviet pride demanded that improvements appear as independent Soviet innovation rather than learning from the enemy's ally. Winter 1942-43 brought the test of survival to Stalingrad, where Sergeant Ivan Petrov received orders that seemed designed to kill him. Supply. Run. To the encircled 62nd Army. 180 kilometers through German-held territory. 4 tons of ammunition and food loaded in a Studebaker US-6. Temperature at -38 degrees Fahrenheit, with heavy snow reducing visibility to 30 meters. Petrov had driven Soviet gas trucks for 2 years before the war. He knew what -38 degrees did to vehicles. Engines froze solid. Fuel lines blocked with ice. Batteries died within hours. The mission should have required a convoy of multiple trucks with mechanic support and preheating equipment. Instead, he received 1 Studebaker, 1 route map, and departure orders for 400 hours. The truck started instantly at 0355, despite sitting motionless overnight in conditions that would have killed any Soviet vehicle. Petrov drove north from the supply depot, following roads that existed more as concepts than actual surfaces beneath the snow. At hour 3, German troops occupying a village opened fire as he passed. Petrov left the road entirely, driving through snow-covered fields where drifts reached half a meter deep. The Studebaker's 6-wheel drive system pulled through terrain that would have stopped Soviet trucks immediately. The all-wheel engagement distributed power across all axles, maintaining traction where 2-wheel drive would have meant entrapment and death. At hour 5, temperature dropped to -44 degrees Fahrenheit. Petrov stopped the engine for 20 minutes while a German patrol passed within 100 meters of his position. He sat in the cab, certain the engine would never restart, already planning how he would destroy the cargo and attempt escape on foot. When the patrol disappeared, he turned the key with no expectation of success. The Studebaker started on first attempt, the engine catching and settling into idle as though temperature was irrelevant. Petrov sat motionless for 10 seconds, processing what had just happened, then continued driving. He reached Stalingrad's perimeter at hour 7, delivered 4 tons of supplies when Soviet trucks could carry 1.5 tons maximum, and received assignment for immediate return trip with wounded soldiers. The Studebaker made 3 more runs that week. Same route, same conditions, same impossible reliability. Petrov's testimony recorded in 1983 stated the facts without embellishment. The Studebaker saved us. No exaggeration. Soviet truck would have frozen. German truck would have broken. American truck just worked. We called them Studers, most reliable comrade in the Red Army. I trusted that truck more than I trusted Soviet officers. By winter 1942 to 38,000 American trucks operated on the Eastern Front. The statistical comparison revealed operational realities that shaped the entire Soviet war effort. American trucks maintained 87% operational rates in winter conditions. Soviet trucks achieved 53% operational rates. Captured German trucks, supposedly engineered with famous German precision, managed only 31% operational rates in Russian winter. The supply tonnage mathematics were undeniable. American trucks moved 60% of all supplies, despite representing only 40% of vehicle count. Soviet logistics planners had assumed they would need 3 Soviet trucks to replace 1 lost Soviet truck. Reality showed they needed 2 American trucks to replace 3 Soviet trucks, and the American trucks would still be running when the Soviet trucks had failed. The Murmansk run became legendary among Soviet drivers as the road of death. 1,400 kilometers from the Arctic port, where British convoys delivered supplies to Moscow, through temperatures that commonly reached -50 degrees Fahrenheit, under constant threat of German bombing. Soviet planners called it the most dangerous supply route in the war. American trucks completed the run with 94% success rate, averaging 6 days travel time with minimal maintenance required. Roadside repairs were possible with basic tools because the simple design allowed field mechanics to diagnose and fix problems without specialized equipment. Cold-related failures occurred in only 3% of trips, remarkable given the extreme conditions. Soviet trucks completed the run with 68% success rate when they completed it at all. Average travel time extended to 9 days when successful, assuming no major breakdowns requiring return to depot facilities. Maintenance demands were extensive and required specialized tools and trained mechanics rarely available on remote routes. Cold-related failures occurred in 27% of trips, with most failures resulting in complete vehicle loss. Senior Lieutenant Yuri Bespalov, chief mechanic for a motor transport battalion, watched the pattern repeat throughout 1943 and 44. His testimony captured the frustration of Soviet mechanics trying to maintain Soviet vehicles while watching American vehicles simply work. We had a joke. Soviet truck works when everything is perfect. American truck works when everything is broken. I watched Studebaker run 800 kilometers with broken front spring, cracked manifold, and leaking radiator. Still delivered load. Soviet gas brakes if you look at it wrong in winter. The joke contained more truth than humor. Soviet trucks required perfect conditions, perfect maintenance, perfect operation. American trucks tolerated imperfection, neglect, and abuse while continuing to function. The final push to Berlin in spring 1945 demonstrated American truck superiority across 2,000 kilometers of advance from the Vistula River through Poland and into Germany. The conditions alternated between thaw mud that swallowed vehicles to axle depth and sudden freezing that turned roads into ice sheets. American trucks performed reliably in both extremes, their simple, robust design handling temperature swings that destroyed more sophisticated vehicles. Marshal Georgy Zhukov, commanding the final offensive, submitted logistics assessments that would remain classified until 1991. The key finding: without American trucks, we would not have reached Berlin when we did. Official logistics reports documented that American vehicles were 2.3 times more reliable than Soviet equivalents under field conditions. The maintenance burden comparison showed American trucks freed Soviet mechanics for weapons systems and combat vehicle maintenance instead of constant transport vehicle repair. By war's end in May 1945, the total count of American trucks delivered under Lend-Lease reached 427,284 vehicles. Operational rates at any given time averaged 350,000 trucks, representing 82% of delivered vehicles still functioning. Soviet estimates calculated that American trucks shortened the war by 18 to 24 months by ensuring supplies reach frontline units consistently. Marshal Zhukov's private assessment, recorded in journals published after his death, stated the political reality that could not be spoken during Stalin's rule. Studer, Spam, Studebaker. We lived on American supplies. Without them, we lose Moscow, Stalingrad, probably the war. This is not exaggeration. This is mathematics. The mathematics of reliability had proven more important than the mathematics of production. Soviet factories had produced more trucks, but American trucks worked more consistently, and in war, consistency was survival. May 1945 brought victory and an immediate crisis for Soviet mechanics who had spent 4 years maintaining American trucks. Lend-Lease deliveries stopped. The Red Army ordered return of all American vehicles to Soviet control for eventual repatriation or disposal. Soviet mechanics were assigned back to Soviet trucks, back to GAZ and ZS vehicles that required double the maintenance hours and delivered half the reliability. Dmitry Volkovich, now chief mechanic for Moscow Motor Pool, received his assignment to train mechanics on the new post-war GAZ-51 model, supposedly improved to match American standards. He examined the first GAZ-51 delivered to his facility in June 1945 and recognized immediately that Soviet engineers had learned nothing from 4 years of American truck superiority. The GAZ-51 used the same basic design philosophy as pre-war Soviet trucks. Tight tolerances that would bind in cold weather, complex carburetor systems that would ice up in winter, hard steel alloys that would become brittle below -20 degrees Fahrenheit. The truck represented Soviet engineering pride unchanged by evidence, doctrine unmodified by reality. Volkovich's maintenance schedule for the GAZ-51 required twice the mechanic hours of a Studebaker, and initial cold weather testing showed 50% operational rates at -30 degrees, exactly the same failure pattern Soviet trucks had demonstrated throughout the war. Motor pool commanders across the Soviet Union submitted identical requests through official channels in late 1945 and early 1946. They requested permission to retain worn-out American trucks instead of receiving new Soviet trucks. The requests were carefully worded to avoid direct criticism of Soviet engineering, but the mathematics were clear. A 5-year-old Studebaker with 100,000 kilometers of hard use was more reliable than a brand new GAZ-51 fresh from the factory. Some units hid American trucks, reporting them as destroyed in combat or accidents, then continued using them unofficially for years. The black market in American truck parts flourished throughout the late 1940s, with mechanics paying premium prices for Studebaker carburetors, starters, and electrical components. Soviet maintenance logs from 1946 through 1950 contained thousands of entries noting "Request American Equivalent" in the comments sections. The phrase became code among mechanics, a way of documenting that Soviet trucks were inadequate without directly stating political heresy. Official policy required that Soviet trucks were superior to capitalist designs. Reality required that mechanics spent their days repairing Soviet trucks while remembering that American trucks had simply worked. Despite official orders, the Soviet Union retained approximately 150,000 American trucks through the late 1940s. The vehicles remained in service through the early 1950s, some lasting into the 1960s in remote Siberian regions, where mechanics maintained them with improvised parts fabricated in local workshops. A Studebaker documented in Magadan in 1963 had been in continuous service since 1943, 20 years of operation in conditions that destroyed Soviet trucks within 3 to 5 years. The mechanics maintaining it had never seen the original parts manual and were fabricating replacement components based on measurements and reverse engineering. The design infiltration happened quietly at Gorky Auto Plant starting in 1946. Chief designer Andrei Lipgart received an assignment to create a Soviet truck matching Western standards. Official designation for a project everyone understood meant copying American designs without admitting it. The result emerged in 1948 as the GAZ-63. A truck with specifications suspiciously identical to the Studebaker US-6. Six-wheel drive system previously rare in Soviet designs. Simplified fuel system with wide passage carburetor. 24-volt electrical system copied directly from American trucks. Looser manufacturing tolerances than traditional Soviet engineering allowed. The official designation stated, independently developed design based on Soviet engineering advances. Engineers working on the project knew the truth. They were building Soviet Studebakers and calling them original designs to preserve political fiction. The ZIS-151 appeared the same year, even more obviously copied from American trucks. Same load capacity of 2.5 tons. Same basic engine configuration with similar displacement and horsepower. Similar suspension geometry and drivetrain layout. Soviet propaganda declared it a triumph of Soviet engineering, proof that socialist industry could match capitalist production. Engineers privately acknowledged they had finally learned to build trucks the American way, and the learning had taken 5 years of war, and hundreds of thousands of Soviet lives lost to logistics failures. American maintenance manuals circulated through Soviet engineering schools in bootleg translations during the late 1940s and early 1950s. The manuals became unofficial textbooks teaching reliability through simplicity, a concept Soviet doctrine could not openly embrace, but Soviet engineers desperately needed to learn. Design principles from American trucks infiltrated Soviet automotive engineering without official acknowledgement. Wider tolerances, softer materials, simpler systems, integrated design where components supported each other. The phrase reliability through simplicity became unofficial doctrine in Soviet engineering departments, while official doctrine still proclaimed Soviet technological superiority. Volkovich's role in the GAZ-63 design remained unofficial and uncredited. He provided detailed analysis of American engineering principles based on his 4 years maintaining Studebakers in field conditions. His technical reports documented exactly why American trucks worked and Soviet trucks failed. Information that proved invaluable to designers attempting to copy American success. His private journal, published in 1993 after his death, contained the assessment he could never state publicly. We spent 20 years catching up to what Americans did by accident. They built trucks for profit and created reliability. We built trucks for ideology and created junk. The Cold War of the 1950s revealed the continuing gap. NATO logistics relied on American trucks and American descendants that maintained the reliability standards established during World War II. Soviet military planning remained constrained by vehicle unreliability that forced commanders to calculate supply capacity based on assumption that one-third of trucks would be non-operational at any time. Winter exercises consistently demonstrated Soviet trucks failing 2 to 3 times more frequently than Western equivalents, a gap that tactical doctrine attempted to compensate for through numerical superiority that never quite materialized. Afghanistan. 1979 through 89 brought the lessons full circle. Soviet trucks struggled in Afghan conditions, mountains and deserts, and extreme temperatures, creating maintenance burdens that crippled logistics. Some units sought black market American truck parts 40 years after Lend-Lease ended, testimony to both the durability of American designs and the persistent inadequacy of Soviet replacements. Soviet military studies declassified in the 1990s identified vehicle unreliability as a significant factor in operational failures throughout the Afghan campaign. The word Studer entered Russian slang during the war years and never left. It meant reliable, simple, works, always regardless of conditions. The opposite meaning emerged organically. Soviet design meant complicated, breaks often, requires constant attention. Veterans throughout the 1950s and 60s and 70s consistently rated the Studebaker as the best vehicle they ever used in military service. Some mechanics kept Studebaker parts as lucky charms into the 1980s. Small carburetors or fuel pumps representing a time when vehicles simply worked. The Soviet archives opened gradually between 1991 and 2000, releasing maintenance records that confirmed what mechanics had whispered for 50 years. The statistical truth emerged in documented numbers that Soviet propaganda had suppressed for half a century. American Lend-Lease trucks delivered from 1941 through 1945 totaled 427,284 vehicles. Average operational rate across all conditions and all years reached 82%, meaning more than 4 out of 5 American trucks remained functional at any given moment. Maintenance hours per 1,000 miles averaged 4.2 hours, less time than Soviet trucks required for preheating alone in winter conditions. Cold weather failures occurred in 6% of operations, remarkable given that most operations happened in conditions below -20 degrees Fahrenheit. Average service life reached 185,000 miles before major overhaul became necessary, 4 times the lifespan of equivalent Soviet vehicles. Replacement rate remained low throughout the war because trucks lasted, requiring Soviet logistics to focus on fuel and ammunition rather than constant vehicle replacement. Soviet truck production during the same period exceeded 600,000 vehicles from all factories combined. Average operational rate never exceeded 57%, meaning nearly half of all Soviet trucks were non-functional at any moment due to breakdown or maintenance requirements. Maintenance hours per 1,000 miles averaged 18.7 hours, consuming mechanic labor desperately needed for weapon systems and combat vehicles. Cold weather failures occurred in 34% of operations, forcing Soviet commanders to assume 1/3 of truck fleet would be unavailable during winter months. Average service life before major breakdown reached 47,000 miles, requiring constant production to replace vehicles that wore out faster than they could be effectively used. Replacement rate consumed factory capacity that could have produced tanks or artillery, a hidden cost of unreliable design that affected overall Soviet war capability. Dmitry Volkovich agreed to an interview in 1995 for a documentary on Lend-Lease. He was 82 years old, former chief engineer with 40 years at Gorky Auto Plant before retirement in 1979. The filmmaker found him in a Moscow apartment filled with technical manuals and journals documenting a lifetime of automotive engineering. On his desk sat a carburetor, carefully preserved, the brass nameplate identifying it as Studebaker US6 production year 1942. Volkovich held it during the interview, turning it in his hands as he spoke. His testimony provided the personal narrative behind the statistics. I thought American trucks were primitive when I first saw one in December 1941. Simple carburetor, thin metal, no winterization. I wrote in my log that these would fail. I was completely wrong. The memory still carried weight 54 years later, the moment when training met reality and reality won. After 500 kilometers, I understood. Americans didn't make trucks for perfect conditions. They made trucks for terrible conditions. Every condition. That was genius we didn't have. The comparison of engineering philosophies defined the deeper lesson. We made trucks that worked perfectly when everything was perfect. Temperature correct, maintenance perfect, operator perfect. Americans made trucks that worked when everything was wrong. That's the difference between theory and reality, between what sounds good in engineering school and what actually functions in minus 40 degrees with no mechanic support and a driver who learned to drive 3 weeks ago. The ideological impact remained painful in memory. I was a communist, true believer. The trucks made me question everything. If we were wrong about engineering, what else were we wrong about? That question haunted me for 50 years. I never found a good answer. The admission came slowly, carefully. The words of a man who had spent decades considering a question he could never ask aloud during Soviet times. The cover-up bothered him more than the initial failure. We couldn't admit it, couldn't say American design was better. So we copied it and called it Soviet innovation. The GAZ-63. That's a Studebaker with a red star painted on the door. Everyone knew. No one could say. I helped design it. I knew exactly what we were doing. We were learning from the enemy and pretending we invented it ourselves. His final assessment connected engineering to history. Young Russians don't understand. We lost Cold War partly because our trucks broke and theirs didn't. Simple as that. You can't win war if you can't move supplies. Americans could always move supplies. We could sometimes move supplies when the weather was good and trucks were new and mechanics were available. That difference, multiplied across 40 years of Cold War, explains why Soviet Union collapsed and America didn't. Other veterans provided supporting testimony that created a chorus of confirmation. Yuri Bespalov, who had maintained both Soviet and American trucks during the war, stated simply, Studebaker was a better comrade than most soldiers. Worked in minus 50 degrees Fahrenheit. Worked in plus 100 degrees. Worked always. Soviet truck was like Soviet system. Perfect on paper, broken in reality. Ivan Petrov, the Stalingrad supply driver, recalled specific details. I drove same Studebaker from Stalingrad to Berlin. Same truck, 3 years, 40,000 kilometers. Only replaced tires and oil. Soviet gas wouldn't last 3 months doing what I did. The Studebaker saved my life 6 times that I can count. Probably more times I don't know about it. Marshal Georgy Zhukov's memoirs, censored during Soviet publication but released fully in 1990, contained the assessment he could not make publicly during Stalin's era. Without American trucks, we would have lost Moscow, Stalingrad, and probably the war. This is not exaggeration. This is mathematics of logistics. Soviet trucks could not have delivered the supplies that American trucks delivered. The difference determined the outcome. Modern legacy of the Studebaker persists in unexpected ways. The trucks that won't die still appear in remote Siberian villages, some still operational 80 years after manufacture. Russian collectors prize them as last working examples of American wartime engineering, paying premium prices for vehicles that represent both victory and uncomfortable truth. Russian military museums feature Studebakers prominently now that truth can be told. The placard reads honestly, "These trucks saved the Soviet Union." The statement acknowledges what could not be said for 50 years. Russian engineering schools still study Studebaker design in reliability engineering courses, using World War II American trucks as case studies in building for worse conditions rather than optimal conditions. The principle has a name now, openly taught. Designed for worst case, not best case. The lesson cost hundreds of thousands of Soviet lives to learn because pride prevented learning it from American examples. Volkovich kept the Studebaker carburetor on his desk until his death in 2003. The simple brass component represented the moment in December 1941 when he examined an American truck and called it capitalist junk, the moment when ideology met engineering and engineering won. He was wrong about the trucks. The capitalist junk outlasted the Soviet Union itself, still running in Siberian villages, while the state that rejected them collapsed into history. In -40 degrees Fahrenheit, ideology doesn't matter. Only engineering matters. The Americans had simply engineered better, not through sophisticated complexity, but through simple durability, not through perfect precision, but through robust tolerance, not through theoretical superiority, but through practical functionality. The trucks proved it every day for 4 years of war and 50 years of peace afterward. Soviet mechanics couldn't believe American trucks never broke down in -40 degrees until they watched it happen. And then they couldn't stop believing it even when ordered to forget.